Form 3 work as tested in the year 2017 KCSE Chemistry Paper 1. This is your Kenyan teacher. Welcome and stay on till the end. Let's begin with question number 4, which tested the topic the mole. So in question 4, we are told that the empirical formula of lead-2 oxide was determined by passing excess dry hydrogen gas over 6.69 grams of heated lead-2 oxide. For part A, we are asked to state the purpose of using excess dry hydrogen gas and why we use excess dry hydrogen gas is simply to ensure that all the oxide, this is to ensure that all the oxide was reduced. We proceed now to part B of question number 4. In part B, we are told that the mass of lead after the reduction of the oxide was found to be 6.21 grams. We were therefore asked to determine the empirical formula of the oxide. So here, the first thing that a candidate was to do was to get the mass of oxygen that was involved, and this we get by subtracting the mass of lead from the mass of the oxide. Mass of the oxide was 6.69 grams and mass of lead, we are told, was 6.21 grams. So this would have given us mass of oxygen as 0.48 grams, and that would be the first marking point for half a mark. From here, we would then prepare a table of elements that were present in our compound. So we had lead and oxygen. We would go for the masses. Lead, we are told, was 6.21 grams, and oxygen we've just found 0.48 grams. From here, we'd go ahead to calculate number of moles. For lead, we would divide the mass by the RAM, which is given here as 207, to give us number of moles of 0.03. For oxygen, we would have 0.48 by 16. Again, this gives 0.03. Half a mark for the division there, a half a mark for the other division, and we can see here mole ratio is 1:1, and that would mean that our empirical formula is lead oxide. For the last half mark, giving a total of 2 marks. We proceed to question number 5, which came from Organic Chemistry 1. In question 5, we are told that the setup in figure 2 here was used to prepare a sample of ethane gas. Ethane gas is an alkane with 2 carbon atoms. So we are told to study the diagram or the setup and answer the questions that follow. So in our test tube here, we have a mixture of B mixed with soda lime. A candidate should know that B is a salt called sodium alkanoate generally, but because we are preparing ethane, we need a sodium alkanoate salt that has 3 carbons. So B would be called sodium propanoate. So this is mixed with soda lime, then heated to obtain ethane, which is then collected over water as shown in our figure 3. So the examiner asked us to name B in part A. And just as we've said, this would be a sodium alkanoate, but with 3 carbons. So we call it sodium propanoate for 1 mark. Next, in part B, we are asked to write an equation for complete combustion of ethane. Ethane has 2 carbons and 6 hydrogens. It would burn in oxygen to give carbon 4 oxide and steam or water. This is an equation that is organic in nature, so state symbols may not be necessary. But if a candidate decides to put them in the equation, then they have to be correct. So for our case, we shall not put them, but of course, we shall balance with a 2 on our ethane. Of course, this is 2, not 6. This is 2. So there's a 2 on ethane, there is a 7 on oxygen, there is a 4 on carbon 4 oxide, and a 6 on steam. For 1 mark. Part C asked us to state 1 use of ethane. And as we know, ethane is mainly used as fuel, but we can also use ethane to produce ethene. This process we had discussed earlier, and we remind our candidates that you can actually obtain an alkene from an alkane. Process is called steam cracking. Let's proceed to question number 6, testing on gas laws. Part A asked us to state Charles' law, and Charles' law simply states that the volume of a fixed mass of a gas, is directly proportional to the absolute temperature. That is temperature on the Kelvin scale, of course, at constant pressure. That would be okay for the 1 mark awarded for that part. Then for B, we are told to explain why the pressure of a fixed mass of a gas increases when the volume is reduced at constant temperature. So for this part, we know that as the volume decreases, what happens is that there is increased what we call bombardment. There is increased bombardment, or what we call collisions of molecules. Collisions of molecules against the walls of the container. Against the walls of the container, which leads to increased pressure. It was awarded 2 marks, so we shall give 1 mark for increased bombardment or increased collisions of molecules against the walls of the container, leading to increased pressure. Question 7 was still from Form 3 work, but this time round the topic being tested was sulfur and its compounds. In question 7, we are told that a sample of water is suspected to contain sulfate ions. We were therefore to describe an experiment that can be carried out to determine the presence of the ions. So what we would do here to get the marks is to add barium nitrate. We can use barium nitrate, or a candidate would go for barium chloride. Then followed by dilute. We can use nitric 5 acid, or we can use hydrochloric acid. Now, if a white precipitate, of course, is formed and persists on addition of acid, then sulfate ions are present. But if white precipitate, if our white precipitate dissolves on addition of acid, then sulfate ions are absent. We are told to describe an experiment to determine the presence. So a candidate was to give negative and positive results for the test. 3 marks, 1 mark for the test, 1 mark for presence of the ions, and 1 mark for absence of the same. With that, we proceed to question number 9, testing on nitrogen and its compounds. Copper 2 ions react with excess aqueous ammonia to form a complex ion. We were asked to write the equation that forms, or rather, we write the equation for the reaction that forms the complex ion. So we know that if I have a solution that has copper 2 ions and I add a few drops of aqueous ammonia, then copper ions will react with hydroxyl ions to form a blue precipitate. This blue precipitate is because of formation of insoluble copper 2 hydroxide. This equation will be balanced with a 2 on hydroxyl ions. Then, when I add excess ammonia here, then my hydroxide of copper would react with excess ammonia from the ammonia solution, and I now get the complex ion with the formula this, and we call it tetraamine copper 2 ions, of course, and some hydroxide ions. This equation will now be balanced with a 4 on ammonia and a 2 on our hydroxyl ions. So this complex ion is called tetraamine copper 2 ions. And of course, the examiner asked us to name it in Part A, Roman 2. But before we do that, let's see how Part A, Roman 1 was supposed to have been answered. Of course, these 2 equations were not necessary. The 1 mark would come from equation 2. But as we always say, we are here to show you how equation 2 is obtained. So now, naming the complex ion, we have the name being tetraamine copper 2 ions. In Part A, Roman 2, an ionic equation for the same would be acceptable, in that here we shall have copper 2 ions reacting with 4 moles of aqueous ammonia to give only the tetraamine copper 2 ions without the hydroxyl ions. That ionic equation would also be allowed. Part B told us to explain why CH4 is not acidic while HCl is acidic, yet both of them contain hydrogen. The answer here is quite easy. We would write that CH4 is a non-polar hydrocarbon. So what happens to it? Hence, it does not ionize in water. So non-polar, the first half mark, and then we would also compare this with HCl by writing that HCl is polar. Hence, ionizes in water. Being polar, the next half mark to score the 1 mark for that question. Let's proceed to number 10. Number 10 tested the mole as a topic. 20 cubic centimeters of ethanoic acid was diluted to 400 cubic centimeters of solution. We are asked to calculate the concentration of the solution in moles per liter. Of course, the relative atomic masses of carbon, hydrogen, and oxygen given, together with density of the acid as 1.05 grams per cubic centimeter. Here, what a candidate would do first is to use the density, whose formula is mass over volume, to be able to get mass of the acid. So we know from here, mass would be given by density times volume. So from the question, we have density of the acid as 1.05, and we are told the volume was 20. This would give us a mass of 21 grams for the acid. Half a mark for multiplication by 20, half a mark for giving us the mass of the acid. From here, a candidate would now go ahead and now calculate now the molar mass of our acid, CH3COOH. So this would be 12 for carbon, appearing twice, added to, we shall go up here, 1 for hydrogen, multiplied by 4, because hydrogen appears 4 times, and this we shall add to 16 for oxygen, appearing twice. That would give us molar mass of our acid as 60, and that would score our next half mark. From here, we now need to go ahead and find the number of moles of our acid, and this number of moles would be given by the mass 21 divided by molar mass 60. That would give 0.35 moles. Now, this number of moles of the acid were present in 400 cubic centimeter of solution. So to get molarity, we would argue out that if 400 cubic centimeter of our acid contain 0.35 moles, how about a liter of solution? So cross multiplication gives 1000 times 0.35 divided by 400, and the candidate was supposed to get 0.875 molar solution of ethanoic acid. So far we have 2 marks. The last 1 mark would have a half multiplication by 1000 for the number of moles divided by 400, and finally half a mark for the molarity. We proceed to question 13, borrowed from chlorine and its compounds. Explain the observation made when chlorine is passed through a solution of potassium iodide. So here we know chlorine would displace iodine, and what we would see is a dark gray or brown solid would be deposited. And why would this be so? We would explain that chlorine is more reactive, which can be replaced by chlorine is a stronger oxidizing agent. than iodine. So what happens is that it therefore displaces what? The iodine from a solution of its ions. It is awarded 3 marks, 1 mark for the observation, 1 mark for chlorine being more reactive than iodine, and 1 mark for displacement. Now to number 16, testing nitrogen and its compounds once again. In an experiment, concentrated nitric 5 acid was reacted with iron 2 sulfate. We are told to state and explain the observations. Here, nitric 5 acid is a strong oxidizing agent, so it would oxidize iron 2 sulfate to iron 3 sulfate. So the observation would be that the mixture changes from green, which is iron 2 sulfate, to yellow, which is iron 3 sulfate, for the first half mark. The other observation would be that brown gas is produced for the next half mark. Then we would now go ahead and explain our 2 observations, that iron 2 ions in iron 2 sulfate are oxidized. They are oxidized by nitric 5 acid to iron 3 ions. So that's why the color is changing from green to yellow. And then we would go ahead and explain why we are producing brown gas. So we'd go ahead and say that, and our nitric 5 acid would be reduced. Actually, we reduce it to nitrogen 2 oxide. But this nitrogen 2 oxide is then oxidized to brown nitrogen 4 oxide. So we've scored 1 mark. The question was 2 marks. So iron 2 ions being oxidized to iron 3 ions would score ourselves the next half mark, and nitric 5 acid being reduced to nitrogen 2 oxide, the last half mark. Now to question number 18, again coming from nitrogen and its compounds. Question 18, we are preparing nitrogen 2 oxide as shown in the diagram below. So we have substance A, copper tannings, and then we have nitrogen 2 oxide being collected over water. A candidate should know that to prepare nitrogen 2 oxide, we need 50% nitric 5 acid here and copper tannings in our round-bottomed flask. And in part A, the examiner asked us to name substance A. This is simply 50% concentrated nitric 5 acid. It is 50% because we are producing nitrogen 2, not nitrogen 4 oxide. Part B is asking us to explain that when the gas jar containing nitrogen 2 oxide is exposed to air, then a brown color is observed. Why is this so? This is so because our colorless nitrogen 2 oxide is usually oxidized to now brown nitrogen 4 oxide. For that 1 mark. Finally, we were asked to write the equation for the reaction which took place in the flask. So here, our copper tannings would react with 50% concentrated nitric acid. We still put AQ because It is just 50% concentrated. This would give us copper 2 nitrate, which is aqueous. We would get nitrogen 2 oxide, a gas, and of course some water. Balancing with a 3 on copper, 8 on our nitric acid, 3 on copper 2 nitrate, then 2 on the gas, and lastly 4 on water. We proceed to question 26. Question 26 is borrowed from chlorine and its compounds. Part A is asking us to define what is meant by the term bleaching. Bleaching is simply removal of original color. Removal of original color from a substance. And we don't end there. We say to become white or colorless. That for 1 mark. Then the examiner went ahead to ask us to write the formula of bleaching agent that is formed when chlorine gas reacts with aqueous sodium hydroxide. Now, when the sodium hydroxide is hot and concentrated, we normally form sodium chlorate 5 with that formula here. But when our alkali is cold and dilute, then we form sodium hypochlorite. So there we are. The examiner didn't specify the nature of the alkali, so any of those two would work. Then we are told to state the role of chlorine in water treatment. Of course, chlorine kills germs. We can replace germs with bacteria, and we can replace the two with microorganisms. For that 1 mark. Candidates, we proceed to our last question in this video. The last question borrowed from Form 3 work for the year 2017 KCSE Chemistry Paper 1. This is question number 28, borrowed from Organic Chemistry 1. When an aqueous solution of compound X was mixed with a few drops of bromine water, candidates, bromine water is testing for unsaturation. So the question went ahead to tell us that the color of the mixture remained yellow, which means that our compound X didn't have unsaturation. That's why bromine water remained yellow. Now, when another portion of X was reacted, this time with potassium dichromate 6, don't forget potassium dichromate 6 is testing for ROH. We are told the color of the mixture actually changed from orange to green. So here, ROH was now present. The examiner went ahead to ask in part A, what conclusion can be made from the use of bromine water? And we have agreed for bromine water, unsaturation, that is C triple bond C or C double bond C, were absent. And that's why yellow bromine water remained yellow for 1 mark. Now, when it came to alkanols, our acidified potassium dichromate 6 actually showed some change. So we conclude that ROH was present. For the next mark, we were finally asked that solution X was reacted with a piece of metal. X, we've agreed, was an alkanol. So alkanols react with metals to produce salts, which we call alkoxides and hydrogen gas. And we are told that a colorless gas was produced. This was obviously hydrogen. So we are asked to describe a simple experiment to identify the gas. What we would do is to lower would lower a burning, the word is burning, splint, to the gas jar full of the gas that was obtained. For the first half mark, then because it is hydrogen, we expect the gas to extinguish. We expect the gas to extinguish the burning splint with a pop sound. With a pop sound, showing that the gas is hydrogen. So pop sound here would give us the next half mark, totaling 1 mark. With that, we've come to the end of our otherwise long video, suggesting to our candidate that this year, 2017, Form 3 work actually formed the bulk of testing in Chemistry Paper 1. We want to wish you all the best in your revision, and kindly keep it right here at the Kenyan Teacher for more of such insightful reviews.